Today we're going to get some information about square roots. Some of this will be review, some will be new information. So make sure you take notes on everything. Let's get started. Okay, so let's take a look at what you're going to learn today. First thing you're going to learn is how to find the square root of rational numbers. Okay, if we remember, sorry about that, I was missing some words here. So find the square root of rational numbers. We did some rational number review before, remembering that rational numbers are numbers that can be written as a fraction, where the denominator is not 0 and where we have no decimals involved. If you have a decimal, the decimal must repeat or must end. It can't just go on forever with no pattern. Okay, so finding the square roots of rational numbers. And then the second thing we'll learn today is how to solve equations involving squared numbers. All right, so the first thing I want you to get copied is some vocabulary. The first vocabulary is for perfect square, so write the word perfect square down, and then I want you to write a definition in words, in symbols, and write down the example, including this picture. So hit pause, get everything copied, and then we'll talk through each portion. Okay, so if we take a look at our words first, a perfect square is the product of a rational number and itself. Okay, remember, our rational numbers are integers. It's a fraction where the b is not 0, a over b, where the denominator is not 0. If it's a decimal, it must end or repeat. Okay, so it's the product of a rational number and itself. If we look at symbols, the way this reads is if x times x equals x squared, then x squared is a perfect square. Doesn't make a ton of sense until you look at it with actual numbers. 3 times 3 is 9, so 9 is a perfect square. If I wrote this example the way the symbols was written, I could say 3 times 3 equals 3 squared, and we already know that 3 squared equals 9. So I just left this x squared part out because we know that 3 times 3 is 9. Now when you have your perfect square, what we're looking at here is my height is 3 and my width is 3. If we look at our side lengths, we have 3 units on each side. And if I total up the inside, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 squares inside. So a 3 by 3 square has an area of 9. Okay, so if we think about this as physically, like literally a square, a 3 by 3 square makes an area of 9. Any added notations that you want to put down, you can. But as long as you have all the basics written, you're good. Okay, one thing that I included last week, and there is a copy of it attached to the post here. This multiplication table has perfect squares. You'll notice the perfect squares are highlighted yellow diagonally down through the multiplication chart. If we notice 5 times 5 is 25. 8 times 8, 64. So our perfect squares are our integers multiplied by themselves. Okay. This definitely is something you want to memorize. These upper numbers, the 16, 17, 18, 19, 20, they're tougher, but the more these numbers you get memorized, the faster this week's work will be and next week's work. So definitely take some time to memorize those. So hit pause, take a minute, go through. You'll be doing a little check on yourself in a little bit. All right, so next up vocabulary is square root. So get everything copied on this page, including the picture. Hit pause, and we'll talk it through when you come back. Okay, let's take a look at the words. The square root of a number is one of its equal to factors. Okay, so the square root of a number is one of its equal to factors. What they're saying is, if we look at our example down below, 5 squared equals 25. If I broke 5 squared down to 5 times 5 equals 25, and we look at this definition, the square root of a number is one of its equal to factors. So if we look at 25, the square root of 25 is one of these numbers. Okay, so the equal to factors would be 5 and 5. I pick one, and that's my square root. So the square root of 25 would equal 1, or excuse me, would equal 5. You have 5 times itself equals 25, so my answer for the square root would be 5. That's all that definition is trying to say. If we look at it with symbols, if x squared equals y, then x is the square root of y. That's a little bit trickier to see, so let's take a look at it as an example. If 5 squared equals 25, so 5 is a square root of 25. So if I look at this, I just replace the x with a 5 and the y with a 25. Then you can see how the symbols in the example match up. Now if I look at the square, my square has 25 squares inside. That gives me a square with sides length of 5. So it's just working backwards from the square root, going the opposite direction. All right, next vocabulary word is radical sign. Now, don't pause quite yet. There's a little bit of room here because we're going to add some extra information. So just copy this first part. Every positive number has both a positive and a negative square root. Okay, so let's take a look what this means. Every positive number has both a positive and a negative square root. So here's what that's saying. If we look back at 25, okay, according to our last vocabulary word, the square root of 25 equals 5. Okay, and that's because 5 times 5 equals 25. Now, think about this for a minute.
We have one more question.
Okay, so now let's think about positive. It says it has both a positive and a negative square root. If I took negative 5 times negative 5, what would my answer be? So what is negative 5 times negative 5? It's also positive 25. So what we're saying is the square root of a number is the number you're thinking plus the negative version of that as well. So we would really say the square root of 25 is 5 or negative 5. We have two options. Make sure you copy all of this information down in red so that you have it in your notes, because this is very, very important. So hit pause to get that copied. Now, when we're working through these problems, I wrote out up above square root of 25. That would take forever if we wrote that every time. So instead of writing square root of in words, we actually use a radical sign. Okay, so this radical sign is used to indicate the square root. So if n squared equals a, then n equals positive or negative square root of a. Here it is an example. So if I asked you for the square root of 25, okay, so if you see this radical sign, I want to take this number inside and say, what number times, oh, that's horrible. What number times itself equals 25? Well, the number that equals 25 is 5, but it's the positive 5 or negative 5. And what we do is we write the positive and the negative on top of each other to show it could be positive 5, it could be negative 5. So this would be an example of how you would write that with the radical and the notation for the positive and the negative. All right, let's take a look at some examples. Find the square root of, number 1 is 64. So we're going to go ahead and draw a radical sign over the 64 because that tells us we're going to find the square root. So what times itself equals 64? Look at your multiplication chart if you need to. But it's 8 but it could be a positive 8 or a negative 8. 8 times 8 equals 64, and negative 8 times negative 8 equals 64. They both work. Number 2. Okay, and the square root of 196 is positive and negative 14. Now for number 13, when we try to square root this, negative 16, if we try to think about this, positive 4 times positive 4 equals 16. Negative 4 times negative 4 equals positive 16. There's nothing that equals negative 16. The only way to make that happen is negative 4 times positive 4 equals negative 16, but the problem is negative 4 and positive 4 are not the same number. Okay, so the square root of negative 16 is not possible. Technically it is possible, but with what we know right now, it's not an 8th grade skill. When you get to high school, you will learn how to deal with a negative number inside the radical. But for right now, for all you know, it is not possible. Okay, let's take a look at some examples when we have fractions. I want the square root of 25 over 36. So we just draw a nice big radical. And what ends up happening is this is actually asking me for the square root of 25 over the square root of 36. Everything inside gets square rooted. So we answer with our positive and our negative symbol. Square root of 25 is 5. Square root of 36 is 6. Plus or minus, positive, negative, 5/6. Number 5, square root of 1 over 225. Square root of, now you don't need to rewrite it this way, but some people find it easier to kind of break everything down. We get 1 over 15. Positive, negative. Okay, we're going to go ahead and stop here and work on some practice.